Hi everyone, this is a video on solving systems of equations by elimination. Sometimes elimination is also called the addition method, so you may have heard it called that before. Remember, when we have systems of equations, what you're really thinking about here is you're going to have two equations and you're trying to find the points where they intersect on a graph. So your solutions will be an ordered pair. In previous videos you might have seen us do this graphically and by substitution method, so elimination is just another way of finding solution. We'll start with an example just to give you an idea of how it works, and I'll write out some formal steps. So if I said to solve the system and the system will be x plus y, or x plus 5y equals 7, I'll label this equation 1, and the next one will be 4x minus 5y equals 3, and I'll label this equation 2. Now, when I look at this, previously you might have seen us try to solve this using substitution method. For elimination method, it's a little different. So first off, we have both equations in the standard form where we have our x terms, our y terms, and then our equal sign, and then our constants on the other side. And just noticing here, if I was to add these together, right, taking a look at what would happen, I'm going to add the same variables to the same variables and the constants with the constants. You only can do this if the equal signs are lined up and the terms are lined up in the same way. If I have x plus 4x, that gives me 5x. If I did 5y plus a negative 5y, it's really the same as 5y minus 5y. These actually cancel out to a 0, right? So they cancel out. Equal sign drops down, and then 7 plus 3 is 10. And what you're left with here is you're left with, a single equation with one unknown variable, which we know how to solve. So if I have 5x equals 10, to solve this, I'm just going to divide both sides by 5 and end up with x equals 2. Now remember, that's not the answer for the entire system. That's the x value for the coordinates where these intersect. To find the corresponding y value, remember, all you have to do is back substitute in. So if I back substitute into either of the originals, I'll just say back sub into 1. But it doesn't matter which one you pick. It should give you the same value for both. Back sub into 1, I would end up with 2 plus 5y equals 7, just subbing in for x there. And then solving this, we'll subtract 2 from each side, end up with 5y equals 5. And then we'll divide by 5 to each side of this. End up with y equals 5 divided by 5, which gives me 1. So my solution here, right, if I'm looking for the ordered pair, as an ordered pair is x comma y, so it'll be 2 comma 1, and that would be your answer. So it seems pretty straightforward. The thing is that the only reason this worked the way I did it is that when I added these together, you have to notice that for one of the variables, either x or y, in this case y, you have to have the exact same terms but with opposite signs. That's what allows them to cancel out. So you can't do this for any set of equations where you just add them right away, because you won't always have that cancellation. And you need to have one of the variables be eliminated. That's why we call this elimination method. And it's eliminated by adding the two equations together. So if these are not the same value in front, you could still eliminate the variable, but you have to manipulate the equations first. And that's really how the process is going to work. So, you can't always just add them together at the beginning. In this case we could, because we had, the same terms here for y, but with opposite signs, which canceled them to a 0 when I added them. So we'll work through another example, and this time I'm going to write out the steps of what you should be doing while you're approaching a problem by elimination. So for this example here, we'll say solve by elimination. And I'll just put addition here in parentheses. So remember, elimination is the same as the addition method. And the first equation we'll look at is 3x plus y equals negative 1. And the second equation will be x equals negative 2y minus 12. Now I want to solve this by elimination. So if you've previously learned substitution, the first thing you might notice is that you have x equals negative 2y minus 12, and you could just substitute that in for x and solve that. And if you did, that'd be okay. But if I ask you to solve by elimination, I'm checking to see if you understand the process. So in this case, we're going to do this by elimination. If I don't give you direction, I just say solve algebraically, you could use elimination, which we're about to learn, or substitution method. As long as you do it correctly, either would be okay. So in solving this by elimination, our first step is that we want to rewrite each equation. All right, so rewrite each equation in standard form, and I'll put in parentheses here if necessary, because the truth of it is that, you know, we could say rewrite it in standard form, and it's already in standard form, then it's not necessary, right? We already have the form. When I say standard form, though, make sure you understand what I mean. Standard form means I want the x terms first, the y terms second, the equal signs, and then the constants on the opposite side of the equal signs. So the first equation is in standard form. So I'm not really going to rewrite it, just going to leave it as it is, but I'll show it over here just so you can see it lined up with the other one. So I got 3x plus y equals -1. And I'm just going to label this equation 1 so we can talk about it. The second equation here, if I have x equals -2y minus 12, to get this in standard form, I really need the y's to be on the left side with the x term. So to move the -2y over to the other side, I'm going to add 2y to each side. So this would give us x plus 2y, and the equal sign, these cancel, -12, and I'll label this equation 2. All right, so we have equation 1 up here, we have equation 2, and now I'm ready for my next step. So once I've rewritten them in standard form, the next step, now we can't just add these together right away like we did in the previous problem, right? Because here, if I added these, the x's wouldn't cancel and the y's wouldn't cancel, so neither of the variables would cancel. Up here we could do it because the variables canceled out immediately. But down here you can't do that. So it's not just add right away. What you really need to do is multiply one of the equations and then in parentheses here I'll put or both by a constant so when they are added, one of the variables will cancel out. Remember, or eliminate, right? That's why it's called elimination. So I'm looking at my two equations, and I want to say to myself, okay, if they don't cancel right away, how can I cancel these out? So I either can try to cancel x's or try to cancel y's, or try to eliminate x's or eliminate y's. You don't want to necessarily do both, right? You want to pick one or the other. So the important thing here is that you have to make the decision on your own what you want to eliminate. And it really doesn't matter which one you pick, but you have to make that choice in order to do the rest of the problem. And that's the part where students have kind of the most difficult time, I think, sometimes, is they don't necessarily know what to pick. So we're going to, just so we choose something, I'm going to choose to eliminate y's. All right, so this is me picking this. All right, so we're going to eliminate y's. If you want to eliminate x's, you could. So if I want to eliminate y's, I need the coefficient of y terms to be the same but with opposite signs. The first term I see, or the first equation I see, has a +1. The second equation has a +2. So I really want to make these both look like the same number in front. The easiest way to do this is if I multiply equation 1 by a -2, because if I multiply this by -2, -2 times y will give me -2y, and I could add it to a +2y. So I'm going to multiply equation 1 by -2. Now you can't just do it to the y term, you have to do it to the whole thing, because that's what keeps the equation balanced. That's what makes this, you know, something you're allowed to do. So I'm going to write it down here. All right, so I'm going to do -2 times, I'm just going to write it as equation 1 like this, and I'm going to write what I have. So it'd be -2 times the 3x plus y, all right, equals -2 times the -1. Make sure you do it to both sides of the equation, right? Every term should get multiplied by this -2. And in doing that, I'm going to distribute through here. So I got negative 6x minus 2 times y is minus 2y equals negative 2 times negative 1, which is a positive 2. Watch your signs here. And I'm just going to label this with a little star just so you can see that's my new equation 1, right? It's manipulated. And then what I want to do really is add it to the other equation, because remember the goal is to add these together so one of the variables will cancel out. The variable I'm trying to cancel is y's. So that was the new equation 1. You want to add it to the other equation. The other equation is x plus 2y equals negative 12. So write that down here. X plus 2y equals negative 12. That's my equation 2. And then we're going to add these. So make sure you put this here, put a plus sign, right? Put that line there, indicating that you're going to add these together underneath. And we'll add them. And I end up with negative 6x plus x gives me a negative 5x. A negative 2y plus 2y, well, those cancel, and they should. We chose to eliminate y's, right? So those cancel to 0y, which is just 0. The equal sign should go here, and then 2 plus a negative 12 is negative 10. All right, so we got negative 5x equals negative 10. And then we want to solve this, right? So step 3, once you've added these together, you should only have one variable left, right? So we want to solve for the remaining variable. So we only have x's left because we chose to eliminate y's. So if I have negative 5x equals negative 10, I'm going to solve this here and divide by negative 5 to each side, divide by negative 5. End up with x equals a positive 2. Remember, that's the x value. You have to find the y value as well because we want the ordered pair where these intersect. The way you find that is by going back to either of the original equations. It doesn't matter which one you pick. You can really even do it in one of the equations that you find in between, as long as you're careful about substituting in. So step 4, I'll say we're going to back sub into either original equation. So if I want to back sub in either original equation, I'm going to just choose, just for myself, right? I'm going to sub into equation 1. Right, so we're going to sub into equation 1 was the 3x plus y equals negative 1, if you remember that from above. And substituting into that, we're just subbing in 2, because that's what x was. So we got 3 times 2 plus y equals negative 1. 3 times 2 is 6 plus y equals negative 1. And then we're going to subtract 6 from each side. So I end up with y equals negative 7. So my solution here, remember, when you get a solution, you want an ordered pair, x comma y. It's the point where the lines cross, so 2, negative 7. The last thing to keep in mind here when you do this is that you don't have to do a full other elimination. Sometimes people go back when they get to this step, after they find 2, and they start doing a whole new elimination to find y. You could do it. It would just take you longer to get through the problem. Once you have one of the variables and you solve for it, you just substitute back in to find the other. The last step, which you don't have to do unless we ask you to do it, is to check. Remember, when you check for these, you check in both equations. And the reason you check in both is to make sure that it's a solution for both lines. Otherwise, the point would only be on one of the lines if it only worked in one of the equations. So you should check in both. In this case, we have equation 1, which is 3x plus y equals negative 1. If I'm checking here, I'm checking 3 times 2 plus a negative 7 subbing in for y. Does that equal negative 1? Well, 3 times 2 is 6. That's really plus and negative makes it minus 7 equals negative 1. Yeah, negative 1. 6 minus 7 is negative 1 equals negative 1. Checks out in equation 1. That tells you it's a point on line 1. You also have to check it in equation 2. Equation 2, you could use the original x plus 2, or x equals negative 2y minus 12, or the x plus 2y equals negative 12. Maybe I'll just check it in the x equals negative 2y minus 12, just to show you that it'll work. Substituting in x we've got 2 equals negative 2 times negative 7 minus 12. We got 2. Does that equal negative 2 times negative 7 is a positive 14 minus 12? 2 equals 14 minus 12. Yeah, that's 2. Checks out. So since it checks in both, then we know the solution does check and that it is correct. So you found the points where the line crosses. Now remember, I chose up here to make a decision to eliminate y's. If you chose to eliminate x's, just looking at the original problem, you could have multiplied the second equation by a negative 3, because then a positive 3x and a negative 3x would then cancel out. You would have found the y value first, though, and then back subbed in to find the x. It works the same way. There's nothing different about it. Just making sure they have an understanding of it doesn't matter which one you pick, but you have to make that choice. All right, let's take a look at another example here. If I said, all right, again, solve by elimination. And we'll look at 8x minus 4y equals 12. I'll label that equation 1. And 2x minus 8y equals 10. We'll label that equation 2. So first thing is you should make sure they're in standard form. In this case, they are. Right, with the x's lined up, the y's lined up, the equal signs, and the constants. And then from there, I have to make a decision. Do I want to eliminate x's or y's? And because I chose to eliminate y's last time, I'll choose to eliminate x's here, but it doesn't really matter which one you pick. All right, so I'll say eliminate x's. If I go to eliminate x's, I want the coefficient of x, right, the number in front, to be the same value, but have opposite signs. So I have 8x and I have 2x. So both of them are positive right now. So I know I have to make one of them negative. So I have to multiply by a negative number. And really, you want to think of this almost like you think about like an LCD. You know, what's the smallest number 2 and 8 can both go into evenly? Or what's the smallest number 2 and 8 are both factors of? In this case, that number is 8. So really, I want to ask myself, what do I multiply 2 by to make it look like a negative 8, right? So I want to make 2 look like a negative 8 because it's a positive 8. So you would multiply equation 2 by negative 4. It has to be negative because we need the opposite sign of what we had above. And we're using 4 because 2 times 4 gives me 8. So it'll give me a negative 8 for the x value. But remember, you have to do it to every single term. So when I say multiply equation 2 by negative 4, what I'm really doing is, right, if I look at it over here, negative 4 times, this will be 2x minus 8y equals negative 4 times 10, right? You got to make sure you do that. And once I have this, I'll distribute through it. So this gives me negative 8x, and negative 4 times a negative 8y is a positive 32y, equals negative 4 times 10 is negative 40. All right, this is my new equation 2. And the goal is, right, to take whatever I got when I did negative 4 times equation 2, right, that's here. Right, so that's what I've got, and I want to add it to the other equation, equation 1. So equation 1, just remembering what it was, writing it down here, equation 1 was the 8x minus 4y equals 12. And we're adding these. That's what elimination method does. You add them together for elimination. So I want to add these together, and negative 8x plus 8x, well, that gives me 0x. They cancel out. And they should. We chose to eliminate x's, remember. For a positive 32y plus a negative 4y, it's really 32y minus 4y, which gives me positive 28y. And it's equal to here negative 40 plus 12. That's going to be a negative 28. Once you've reached this step, you know you should only have one variable remaining, right? We chose to eliminate x's, so we should only have y's. And then to solve for y, we just solve this equation. So we divide both sides by 28, and we get y equals negative 28 divided by 28 is negative 1. And from there, remember, you're not finished. You found the y value, but we need an ordered pair because these are two lines that intersect. So we want to find where these graphs intersect. So we back sub, doesn't matter which one you back sub into. I'll say back sub into equation 1. It doesn't really matter. So I have 8x minus 4 times y, which I now know is negative 1, equals 12. Simplifying this, I end up with 8x, negative 4 times I was a positive 4, equals 12. And then we'll subtract 4 from each side to isolate the x term. So you get 8x equals 8. And then you're going to divide by 8, divide by 8. End up with x equals 1. So my solution here is, remember, x, then y. It doesn't matter the order you found them. Always x comes first. So it's 1, comma, negative 1. That's the point on the graphs where these lines will intersect. Now, you could do this, looking at it in terms of eliminating y's first. If I was to eliminate y's first, looking at this, I have a negative 4y and a negative 8y. I would want to multiply the first equation, right, equation 1, by something to make this negative 4 look like a positive 8, because I want it to be able to cancel with the negative 8. So I would have multiplied this by a negative 2, because negative 2 times negative 4 gives me a positive 8. But you'd have to do the whole equation. If you did that, you would have found the x value first and then solve for y by back substituting. Either method is okay. You could always check this by checking in both equations. I'm not going to check all of them though. Next example, we say solve by elimination. So I've got 3x plus 5y equals 11. I'll label that equation 1. And 4x minus 2y equals 6, and I'll label that equation 2. So taking a look at this one, again, first thing, we have standard form, which is important. We have the x's lined up, the y's lined up, the equal signs lined up, and then the constants. And then from there, you want to decide how to solve by elimination, meaning you want to eliminate x's or y's. You have to make that decision. It doesn't matter what you pick. All right, in this case, I'm going to choose to eliminate x's, let's say. So to eliminate x's, I want the value in front of x to look like the same value, but have opposite signs. And in the previous examples we had, the values that were in front of whatever we were eliminating were multiples of each other, meaning I could just multiply one of the equations by something to get the other value I needed. In this case, that isn't true, right? 4 isn't a multiple of 3, so I can't multiply 3 by some whole number to get to 4. I mean, you could do it by a fraction, but that'd be a little more challenging to work with. The easiest way to do this is try to make these numbers in front look the same and have opposite signs, which we've talked about. And I mentioned it in the last example. You want to almost think of this like finding the LCD. What's the smallest number 3 and 4 are both a factor of? And if you can find that, you want to make them both look like that number. So if I'm looking at 3 and 4, the smallest number they're both a factor of, the LCD in other words, that would be 12. Well, how would I make these look like the same number but opposite signs? Well, if I multiply the first equation, right, so I can do 4 times equation 1, so it'd be 4 times 3, give me 12 here. Then I multiply the second equation by, well, I need it to be times 3 times 4, right, to give me 12, but I need it to be a negative here, so it's really negative 3 times equation 2, right? So because negative 3 times 4 will give me a negative 12. So 4 times 3 will give me a positive 12 for the first one, negative 3 times 4 will give me a negative 12 for the second one, and then we can work with this. So you do 4 times equation 1 and then add it to, right, negative 3 times equation 2. So that's what we're going to do. And that's because I chose to eliminate x's. If you chose to eliminate y's, you do something different. So if I do 4 times equation 1, right, we'll do this part here first. 4 times equation 1 would be 4 times, you've got 3x plus 5y equals 4 times 11. Make sure you do it to both sides, right? If you don't multiply both sides, then you're not keeping the equation balanced. You're not allowed to do that. So distributing through this, I end up with 4 times 3x gives me 12x. 4 times 5y gives me plus 20y, and well, we don't need to actually show it as distributing because we already wrote on the other side. 4 times 11, so this equals 44. And then we'll do -3 times equation 2. Now remember, I'm doing -3 here because I need these signs to be opposite, and right now they're the same. If the signs were already opposite, then you wouldn't have to worry about multiplying by a negative. But here we do because we need to make the signs opposite. So we're going to take -3 times 4x minus 2y equals -3 times 6. Right? Just multiplying both sides of this by -3. And then what do we get? Well, distributing -3 through, we get -12x. -3 times -2y is a positive 6y. And that's equal to -3 times 6, which is -18. Once you've done it, remember what we're doing. We're doing elimination method, which means we're adding, right? Elimination is also called addition. Adding these back together here, 12x plus a -12x, well, that's 12x minus 12x. They cancel to a 0, which is good. Our goal was what? Eliminate x's, so they eliminated. If they didn't eliminate here, you know, you would have to go find an error that you made. Positive 20y plus 6y is a positive 26y. It's equal to 44 minus 18, which ends up being a positive 26. Now that x's have been eliminated, now we just want to solve for y. We have 26y plus 26. To solve this, we divide both sides by 26. We end up with y equals 26 divided by 26 is just 1. Now you could get fractions here. If this comes out to a fraction, then you get a fraction. That's okay. A lot of the times you'll see them come out to integer values because we're testing you on the process, but getting a fraction would be all right. Remember, we're not done yet. Remember, we're trying to find the coordinates, right? The point where these intersect. So we've got the y value. You want to go back now, and we'll back sub into either original equation to find the x value. I'll back sub into 2 this time. Doesn't really matter which one I pick. So make sure you're substituting in for the right variables. This becomes 4x minus 2 times, now we know y is 1, equals 6. And this becomes 4x. -2 times 1 is just -2, equals 6. We'll add 2 to each side to isolate the x term. We get 4x equals 8, and then divide by 4. Divide by 4, you get x equals 2. So the solution as an ordered pair is x comma y is intersect at 2 comma 1. So we chose to eliminate x's. In this case, you had to multiply both equations by a constant in order to make these eliminate. Just make sure that whatever you're eliminating, they have opposite signs but with the same value in front. Suppose you wanted to eliminate y's first instead. You could have. Looking at, this is a positive 5y in equation 1 and a negative 2y in the second equation. You want to make these look like the same value in front, right, but with opposite signs. The easiest way to think about it is like finding an LCD. The smallest number 2 and 5 are both factors of it. The smallest number they both go into evenly. So I'd want these to both look like 10. One positive, one negative. We already have the positive and negative here, so you'd be all set. You'd multiply the first equation by positive 2, because 2 times 5 would give me 10, and multiply the second equation by a positive 5, because 5 times a negative 2 would give me negative 10, and then you'd be able to eliminate y's. So there is more than one way to do this, and it's important to understand that your way might not be the same way I show, but it might still work. Let's take a look at this one here. I said solve the system by elimination. So we would have, let's say, 5x plus 7y equals negative 18. I'll label that equation 1. And the second one, 9x minus 3y equals 30. We'll label that equation 2. And you might want to pause the video here and try this one on your own, and then watch the solution. But let's take a look at it. So for me, first off, I notice it's in standard form. I've got the x's lined up, the y's lined up, and the constants on the other side of the equal sign for each equation. And I'm going to choose to eliminate y's this time. All right, my preference, but you could have picked x's. Doesn't really matter. So to eliminate y's, I want the coefficient of y to look the same but have opposite signs. They already have opposite signs, which is good because I don't have to really worry about multiplying by a negative at all. So I've got 7 and a negative 3, and I want to make these both look like the smallest numbers. 7 and 3 can go into evenly, which in this case, the smallest number of the LCD for 7 and 3 is 21. So I'm going to try to make these both look like 21. So you have to ask yourself, well, what do I multiply the first equation by to make it look like 21? Well, 3 times 7 gives me 21, so I'm going to do 3 times equation 1. All right, and then for the second equation, if I have negative 3 here, to make it look like a negative 21, I multiply it by a positive 7. So 7 times equation 2 in this case, because this is already opposite signs, so you don't have to worry about making one of these negative. They already have opposites. 3 times 7 will give me 21. 7 times the 3, or the negative 3, will give me negative 21. If you ever get stuck, you could always multiply these by each other, even if it's not the lowest. In this case, it is. But all right, let's take a look at what happens when you distribute this through. So we're going to do 3 times 5x plus 7y equals 3 times negative 18. And distributing that through there, you end up with 15x. 3 times 7y gives us a positive 21y. And 3 times, it's equal to 3 times negative 18, which is negative 54. And for the second equation, we're doing 7 times 9x minus 3y equals, make sure you do it on both sides, 7 times 30, that's what keeps it balanced. And you end up with, distributing through, 7 times 9x gives me 63x. 7 times negative 3y gives me negative 21y. It's equal to 7 times 30, which gives me 210. Now remember, we call this elimination method because we're going to add these together to eliminate one of the variables. Make sure you know you're adding here. So 15x plus 63x ends up giving me 78x. Positive 21y minus 21y, well, those cancel out. They should. We chose to eliminate y's, right? That was something that we chose at the very beginning. And it's equal to, make sure you have your equal sign. Negative 54 plus 210 is 156. Once you have that, 78x equals 156, right? You've eliminated y's. You only have x's. You can solve for this. You divide both sides by 78. You end up with x equals, in this case, 156 divided by 78 comes out to positive 2. And then remember what you do with this. You want to back sub to get the other coordinate. So don't stop there, right? So back sub, in this case, doesn't matter which one you pick, but I'll pick into equation 1. Equation 1 plus 5x, so 5 times x is now 2, plus 7y equals negative 18. 5 times 2 gives me 10, plus 7y equals negative 18. We're going to subtract 10 from each side to isolate the y term. I get 7y equals negative 28. And then we'll divide by 7 to each side. We end up with y equals negative 4. Right, negative 28 divided by 7 is negative 4. So my solution is x comma y is 2, negative 4. That's the point where these two lines intersect. All right, so 2, negative 4. You could check this, remember, by substituting it into both equations, making sure it works in both. If you had chosen to eliminate x's at the beginning of the problem, you would want to look at the coefficients of x, the 5 and the 9, and make them look like the same number with opposite signs. So in this case, they both had positive values, so one of them would have to get multiplied by a negative to get opposite signs. If you're looking at the 5 and 9, you probably want to multiply the first equation by 9 to get a 45, multiply the second equation by a negative 5 to get a negative 45. So either way it would work. You would have just found the opposite variable first, and that's okay. It's not a big deal. The important part is that you understand how the process works. Sometimes when people do this, they try to go back to using substitution, and that's okay too. Either method will work. Something like this problem here where, all your coefficients are numbers other than 1 lends itself better to elimination. If you had a problem that had coefficients that were 1 in there, kind of like what we did at the very beginning of this lesson up here, you might want to try to use substitution on something like that because you could easily isolate x or y and substitute in. So it's really your personal preference, but also, elimination is very valuable as you go forward in math. And you really should know the method, especially because not everything's going to have a coefficient of 1. Let's take a look at a couple special cases just to make sure you understand what to do with them. If I said solve by elimination, if I had negative 3x plus 2y equals 12, I'll label that equation 1, and 6x minus 4y equals 5, I'll label that equation 2. And I want to solve by elimination. So first off, they're in standard form, which is good, right? We have them both lined up properly. And I'm going to eliminate, it doesn't matter what I pick. Let's say I'll choose eliminate y's. If I want to eliminate y's, I need the same value in front of y with opposite signs. Well, we already have opposite signs, which is good. So if I wanted to do this, I want to make, this look like the smallest number 2 and 4 both go into evenly for their coefficients, which in this case is 4, right? The LCD between 2 and 4 is 4. So the second equation doesn't have to be manipulated. So what do I multiply equation 1 by to get a positive 4? Well, that'd be multiply 2 times 2. So we're going to do 2 times equation 1, and we're going to add it to equation 2 because we don't need to change equation 2. Well, 2 times equation 1 is 2 times negative 3x plus 2y equals 2 times 12. We'll distribute through. 2 times negative 3x will give me negative 6x. 2 times 2y gives me a positive 4y. It's positive 4y. And it's equal to 2 times 12, which is 24. The second equation doesn't need to be manipulated at all because it already has the coefficient we need. So I'm just going to write it underneath. So we got 6x minus 4y equals 5. And then remember, elimination means you want to add these together to eliminate one of the variables. So negative 6x plus 6x, well, that actually cancels the 0x. Now, that's by happenstance, right? I didn't choose to eliminate x's, I chose to eliminate y's, but these cancel, and that's okay, it can happen. So that goes to a 0. Positive 4y minus 4y, well, those cancel to a 0y, and that should cancel because we chose to eliminate y, so that cancels. So this entire left side just became 0, right? It's like 0 plus 0 is just 0. It's equal to, on the right side, 24 plus 5 would be 29. So we have a situation here where all our variables canceled. Remember, when you have this come up, right, and you get something that's false, right, we call this a contradiction. So when you get a contradiction, all your variables cancel out, and you get some equality that's not true, right? A contradiction is false. 0 does not equal 29. Then that tells you that there is no solution. In other words, the lines never cross, right? That's what we're trying to find. The points where these cross is telling you they never cross, and that's because they're parallel lines. But the important thing to know is that the answer is no solution, right? That these don't ever cross. The reason they don't cross is because they're parallel lines. If you were to get these both into the y equals mx plus b form, they would have the same slope, but they would have different y-intercepts. So they'd be different lines, but they have the same slope. If you have the same slope, the lines are parallel. It's not necessarily obvious from the beginning of the problem, though, so that's why I want to make sure you saw that. We'll look at one more. If I said to solve the system, and I gave you 2x minus 5y equals 6, I'll label this equation 1, and negative 4x plus 10y equals negative 12, I'll label that equation 2. And again, they're in standard form, so we can use elimination on them pretty easily. All right, the x's are lined up, the y's lined up, equal signs, and the constants. And I'm going to choose eliminate x's this time. All right, choose either variable. But you have to make a choice, so I'm going to choose to eliminate x's. To eliminate x's, I need the coefficient of x to be the same number with opposite signs. Well, right now we have opposite signs, which is good. And 2 times what would give me a 4, because I need to make this a positive 4 here. Well, this will be 2 times a positive 2. Right, so we're going to do 2 times equation 1. And we're going to add that to equation 2. So when these coefficients are multiples of each other, it's kind of nice because you only have to manipulate one of the equations, not both. Right, because we want to look to see what smallest number that 2 and 4 both go into. They both go into 4. So 2 times equation 1 be 2 times 2x minus 5y equals 2 times 6. And then we'll distribute through that. 2 times 2x will give me 4x. 2 times negative 5y gives me negative 10y equals 2 times 6, which is 12. And equation 2 doesn't change because we already have the coefficient we need. So this is just negative 4x plus 10y equals negative 12. So it's the same equation 2 we had at the beginning. And remember what you're doing. You're doing elimination method, right? So you want to add these together so things will cancel out. 4x plus a negative 4x, well, those cancel. We tried to eliminate x's. That's 0x. Those cancel out nicely. Negative 10y plus 10y, those also cancel to a 0. Again, this is just by happenstance, right? We didn't choose to eliminate y's, but they happen to cancel as well. So this entire left side just became 0. It's equal to, on the right side, we have positive 12 plus a negative 12, so 12 minus 12, which gives me 0. And again, all my variables canceled, similar to the previous case. But is this true or false? Well, 0 equals 0, that's always true, right? So this is always true. We call this an identity. But what it really tells us is that every point on line 1 is also on line 2. In other words, they're the same lines. And if they're the same lines, then the actual answer is that there is infinitely many solutions. And that's really what you should tell me is the answer if this comes up, or an infinite number of solutions. Don't try to abbreviate this as like IMS or something like that. I have to understand that you understand what you're finding. So there's infinitely many solutions, meaning every point on the first line is also on the second line, meaning they're the same line. So if all your variables cancel and you get something that's always true, an identity, like 0 equals 0, right, that's infinitely many solutions because the lines are exactly the same. If you were to get these into the y equals mx plus b form, they'd have the same slope and the same y-intercept. If you have everything cancel out like we did above here, and you got a contradiction, right, so all the variables cancel, you got a contradiction, that's false. That tells you the lines are parallel, so there is no solution. They never cross. So using this video, you know, you've learned how to solve by elimination. You also know how to solve by substitution from a previous video. Either method's okay. As I mentioned earlier, I would choose elimination if all my coefficients were something other than 1. If I had coefficients that were equal to 1, I'd probably use substitution because it's easy to manipulate it. So hopefully this video helps.